All right, well, good morning, everyone. I hope everyone is well caffeinated for today and awake, because it's been, I can't believe it's Wednesday and it's already been quite the week. So this is a session about hybrid and multi-cloud desktops. My name's Sean Massey. I work for VMware. I'm a staff multi-cloud architect in our multi-cloud strategy and architecture team. And I kind of sit in that space between our multi-cloud products and our end-user computing products. I'm a VCDX from Wisconsin, and contact info, blog, et cetera is up there on the screen. So with all things desktops and cloud, there's a lot of talk about licensing, and there's been a lot of changes in this space, both from the VMware side and from other parties that are involved in this. So I'm not going to talk anything about licensing, all right? There's a lot of other sessions that are like our official, breakout sessions where people will talk about that. So I don't want to bore you. Plus, I hate being a sales guy at these things. But the other big thing with licensing is Microsoft, and I'm not going to touch that with a 10-foot pole. There's a whole bunch of people you can talk to who are experts in Microsoft licensing, and if you ask 3 of them, you'll get 6 different answers. So those are the people you probably want to talk to. So to get started, right, what do we mean by hybrid desktops and multi-cloud desktops and multi-cloud Horizon? So it's like anything else when we're talking about hybrid and multi-cloud, right? Hybrid is you have your on-premises footprint and you're extending to, the cloud, either one cloud or multiple clouds. And multi-cloud is across multiple clouds. Now, in the Horizon context and then the VMware context, that typically means, you have your on-prem vSphere environments, and you have one or more cloud-based VMware SDDCs, whether it's VMware Cloud on Azure or VMware Cloud on AWS, or our partners services like Azure VMware Solution or Google Cloud VMware Engine. But there are a couple of other things now where we are starting to do things with Horizon 8 and native clouds as well. But as we think about this, right, we're talking about extending Horizon 8 to the cloud. Well, aren't these the same as like multi-site on-premises Horizon environments? Well, kind of. There's a lot of similarities here, right? There's a lot of the same problems that we have because we're just taking Horizon and moving it to another site. But there's some key constraints and differences that we need to consider when we talk about doing Horizon in the cloud versus Horizon on-prem. And the first thing is that operational models here are different, right? When we are working on-prem, we own the full stack. We have to maintain everything from the hardware on up to the desktop. But as we move to different clouds and cloud-based SDDCs and partner-based solutions, those bottom layers become somebody else's responsibility. We don't have to maintain vSphere. We don't have to troubleshoot the hardware. We're paying somebody else to do that for us. So now we as operators can focus on the top ends of that stack. Now, this varies by cloud, right? Some partners will manage everything except the desktop for you. Some solutions will just manage the hardware and the SDDC, and then there's Oracle, which, they deploy the SDDC for you, but then it becomes your responsibility afterwards. So you can choose the level of management that best suits you and your business, and so you can focus on what's most important, which is making sure that your end users have access to their applications. Now, the second thing is networking, right? Networking is always a challenge with the cloud because the cloud itself has different networking models. The network itself is a shared service between you and other tenants. So the biggest thing with Horizon on a cloud-based SDDC is NSX. And that NSX T0 that sits at the edge of your SDDC is going to be the bottleneck because it is a software appliance right? It's sized for what a typical workload is, but desktops aren't necessarily a typical workload. And the reason for that is twofold. One, everything that your users are going to be doing in their desktop has to transit out that T0. So if they're accessing file servers, if they're accessing applications, if they're trying to go back on-prem for something, all that traffic has to flow through there. But that's also where all their protocol traffic comes through. So when those users are accessing their desktop, when they're looking, when they're interfacing with it, they're seeing the screen, that's also being scraped and sent through the T0 back to their endpoint. So you have all this traffic going through one point. Now, it's not necessarily different from on-prem because you still have your core routers, you still have your core firewalls that all the traffic flows through. But that NSX edge is not dedicated hardware, right? Your dedicated firewalls and routers can do, millions of flows per second and millions of packets per second and analyze and do all their networking magic with it. Well, NSX can do that too, and it does a great job of it, but it's a lot smaller, right? And it's sharing hardware resources with all your other workloads because it's sitting in the same SDDC. When we talk about hybrid and multi-site, there's one other constraint that gets layered on top of this, though, and that's protocol traffic hairpinning. So with Horizon and Cloud Pod architecture, which is our main method of doing site-to-site connectivity or site-to-site pairing between Horizon environments, if my user connects to like a global load balancer and it directs them to one site, they're going to hit the UAG on that site, authenticate, but then if their desktop is in another site, their whole traffic flow is going to be sent back out the T0 and through. So now that one user has two traffic flows through that T0. They're doing twice the number of packets per second that they would be doing if their desktop was here, on top of all the other traffic that's going to be flowing through that for applications and file servers and things like that. So this can significantly cut the number of desktops we can support in a cloud-based SDDC. Now, that's if they're hitting one cloud and going to another or going back on-prem. It's not necessarily the same if they're landing on-prem and going to the cloud because our routers typically on-prem can typically handle that traffic flow. Now, there's one other thing we need to consider with networking, and that's, well, they're going to take their cut of money on all traffic heading out, right? You can get all your data in for free, but you have to pay to get it back, or you have to pay to get it somewhere else. So there's outbound networking charges for any traffic that leaves that cloud or that SDDC. So you have to factor that into your design. And this is an older graphic, but it kind of illustrates the concept for VMware Cloud on AWS. I'll be honest, I don't know if these prices are still accurate or if they've changed since this graphic was made in 2018, but I pick it to illustrate the concept here, right? Everything coming in is free. Everything going out or going cross-region or going cross-AZ, you're paying per gigabyte for. So when you start looking at doing desktop services in the cloud and supporting the things that need to make the desktop work, like file servers and replicating files, you have to take this into consideration. Because one of the things that kills cloud projects the most is unexpected costs, and network is a big driver of that. Right? How many people does anybody have any experience where their CFO gets the cloud bill and goes, this is like 3 times higher than we expect? And a lot of that's driven by networking costs, things that weren't planned for or weren't budgeted for. So what does a multi-site or multi-cloud Horizon reference architecture look like? So before I talk about that, I just want to level set on our typical Horizon reference architecture components. And we do something called the block and pod design. The block and pod design is where we have a management block, which is this bottom layer here, of our connection servers, our vCenter, our database servers, and anything that's really going to support the Horizon deployment. This is all the management stack. Then we have what we call a resource block. The resource block is where we're going to run our desktops or our published app servers. And this makes for a very scalable architecture. So if we want to expand our Horizon environment beyond what one vCenter could support, or we want to have desktops in one and published apps in another, we can just scale this out by adding additional resource blocks that all connect back to the connection servers and UAGs in this management block. Now, we also have an integrated design where all of this runs in a single resource block, where we have our management with our connection servers running with our desktops or our published app servers and our vCenter. And this is kind of an integrated design, typically seen with something like VMware Cloud Foundation, or in really small environments where, a couple hundred desktops or very special edge use cases. Well, we can translate these designs to the cloud. And that integrated model maps up nicely with what we call our all-in SDDC model. The all-in SDDC model is our cloud-based SDDC, all of our management components, and all of our desktops running inside the same environment. And it maps up pretty cleanly to that on-premises model. We also have a federated model. Now, the federated model is very similar to the traditional block and pod architecture because we are now making our management block the native public cloud service. So for AWS, as an example, this would be putting all of our management components in EC2. For Azure, this would be putting everything in Azure VM, and Google would be in Google Compute Engine, right? So we're able to make this our management block, and then we scale by adding additional SDDCs as we need them. So we can avoid some of that hairpinning that we talked about earlier, because now all that traffic coming into the desktop is coming through whatever our native cloud service is, and then going through the backbone to that cloud-based SDDC. Now, we have one other way we can do a federated model, and that's what we call remote vCenter and remote agents. So we have the ability to take like an on-premises Horizon environment and connect it to a remote vCenter in another location. And then we can provision against that SDDC in that remote location. So we can extend our on-prem environment without having to deploy a whole second Horizon pod. Now, this does have some networking requirements. You have to have a fast, low latency connection. And by low latency, I mean less than 120 milliseconds round trip. So it needs to be fairly local. You're not going to be doing this, across an ocean to an SDDC in Europe or in like Australia, as an example. But all you have to do, right, when you go to add a vCenter, you just select the type of vCenter you're using and the URL or the URL to it, and it's that simple to just to connect a remote vCenter, and it works fairly well. And then you just get another resource block, even if it's remote to your location. So just to kind of summarize, right, the two deployment architectures that we have, the federated model is where we put all our management components in a native cloud platform, right? All of our desktops and RDSH servers are located in our cloud-based SDDC, the cloud-based VMware environment. And we can scale that using multiple SDDCs. Now this, because we're putting all our management in a cloud environment, we can scale this. We could scale this to be fairly large. Now the drawback of this is that you need to have native cloud platform knowledge, right? So if you're doing it in Azure, you need to have people who know Azure. If you're doing it in Google, you have to have people who know Google so they can get all the firewall rules and networking and all the constructs set up correctly. Now this compares to the all-in SDDC model that I mentioned. The all-in SDDC model puts everything in the SDDC. Our pod boundary becomes that boundary of the SDDC. And this is small to medium scale, typically no more than 1,500 desktops, although that will depend on your workload and the particular cloud. And you don't need as much cloud platform knowledge because you're not consuming native cloud resources to set this up. So high level, when we do Horizon in the cloud and we start factoring in all of our services, this is kind of what it looks like, right? You know, we have our Horizon environment, whether it's all in SDDC or deployed in the native public cloud. We have things like Active Directory, our file servers, things that we have to be able to replicate and connect from on-prem to the cloud. So we also recently started introducing a new deployment model for Horizon 8 in Amazon, and that's with support for Horizon on Amazon Workspaces and Amazon EC2. There's an article up on TechZone for this that walks through all of what you can do. This fits our federated architecture in a lot of ways. But it also gives you support for things that you can't get today, like GPUs. And there's some Microsoft licensing things that go along with Workspaces, which I promised I would not talk about. The drawbacks to this approach, though, today are you're deploying to a native public cloud platform. So there's no provisioning management. There's no power on management, right? You have to do all this manually and then add it back into Horizon. But you do get the ability to do like remote agents. So you can still deploy in EC2, and then if you have a connection to Azure or Google or whatever cloud or back on-prem, you can still connect that and manage it all from a cloud-based location. Just keep in mind, though, that you are still being charged for any network traffic leaving Amazon. Yeah. So, and then we have KBs that talk about feature parity and what's supported for Horizon on all of our public clouds. These KBs are updated fairly regularly as the platform and our Horizon capabilities change. So if you are looking at one or more public clouds, it is definitely a good idea to check these on a regular basis. So, having talked about reference architectures and everything like that, we can't just focus on the Horizon pieces. Success for any desktop project in a hybrid or multi-cloud or even multi-site deployment depends on a lot more than just having a good Horizon architecture. Because when I go back a couple slides, we have all of these pieces here that Horizon relies on, like Active Directory and our file servers that we need to design for. So let's start first with Active Directory, right? This is probably one of the biggest things because without Active Directory, Horizon doesn't work, right? Horizon relies extensively on this, not just for authentication of users, but also for provisioning desktops. You have to have Active Directory there so it can actually create the desktops that users log into, because it's going to create computer accounts for them and make sure that they're joined to the domain and everything's working properly. So the best practice and what I recommend to customers and partners is you should have a full-fledged writable domain controller near that Horizon environment. And by near, I mean in that same cloud region, availability zone, whatever, right? Read-only domain controllers are problematic because if it can't reach back to a writable one, users can't authenticate. Computers can't join the domain. If you don't have one nearby and your network goes down, your environment is effectively down. And there's a lot of other complex things you can do with this, like having a cloud-native Active Directory service that you set up a trust with, or do multiple trusts. But that has a lot of complexity. And for some organizations that aren't used to that, it adds additional management overhead. So what I recommend, try to keep your Active Directory topology simple, keep your domain controllers nearby, and make sure AD sites and services. This is another thing, right? As you add new sites to Active Directory, you have to set up site links, you have to set up replication. You need to make sure that those are set up and that way the desktops and the users know where to find the nearest domain controller to authenticate. So that also has some performance implications for things like group policy and login times. So as you can see, right, Active Directory plays a huge role in this. Now, when you talk to security people, and this might not be as true now as it was 5 years ago, but there's still a lot of people who hear domain controller in the cloud and panic. It's like, I can't do that. We can't put a domain controller there. It's the keys to the kingdom. If somebody gets it, they have full access to the environment. Well, that becomes a trade-off then, right? There are ways to secure domain controllers in the cloud. There are other ways to accomplish what you would need to accomplish to deploy Horizon in a cloud scenario. But if security people come in and say, no, we're not going to do this, or we have concerns about this, you have to start talking about the other impacts to the environment, right? Availability becomes a big one, right? I can make this secure, but the availability goes down. And availability is key. You need to have that domain controller available. And it also affects performance. Because if my domain controller is on the far end of a WAN link, whether it's a 100 meg or a 10 gig link, that's still latency. My desktops have to check in with that domain controller. They have to download group policies. My login time just at least doubled by doing that. Manageability also becomes a concern here, because I mentioned, right, there's cloud-based Active Directory solutions that are managed for you. You could set up separate domains. But then that means you have to deal with trusts and cross-forest group policy processing and making sure that referrals are set up correctly so that users can find the correct domain controller. Database, this one's less of a concern in the cloud, just because for most things, you don't actually need a database unless you're doing app volumes. You don't need a database for Horizon, although it helps for the event database. And there's a lot of cloud-based services you can tap into to have a database solution. File servers are the other big thing, though, that you need to consider. Your Windows file server is critical, especially if you're doing profile management and you're capturing that profile data with a dynamic environment manager or another tool. You have to have file servers near the environment, but then you have a whole bunch of options and a whole bunch of choices, right? Where do I put my file servers? Do I do Windows in the SDDC? Do I do Windows in the native cloud service? Do I do some sort of cloud native service? Am I using something like Pure Storage on-prem, and can I use their virtual appliance? So those all factor into your choices, and those all impact cost. Cost being the biggest thing in your design considerations. Now, you also have to consider things like the size of your data set, the rate of data change, because that's going to determine how much data gets replicated back and forth. And again, that goes back to cost. But you also have to consider, where am I going to place that data? What impact is it going to have on my user performance, or my user experience and performance? So key takeaway here, because I know we're running up on time, you can do Horizon across multiple clouds. You can stretch from on-prem to the cloud, and you can do it by you can deliver a good user experience by doing this. You just have to keep in mind everything around Horizon in order to deliver that good experience. Finally, we have a bunch of reference architectures up on TechZone. The QR code takes you to our reference architecture page. And I want to make Al happy by finishing a minute early, so I want to say thank you for coming. If you have questions, I'll be over here getting unmiked. So thank you.